All right, so you just learned the definitions for the correlation coefficient and the line of best fit. On example 1, it says Hugo's Hot Dog Hut has been advertising specialty items. During a 10-week period, Hugo kept a record of the number of advertisements and the number of specialty items sold each week. So in week 1, he had 6 advertisements and 150 items sold. In week 2, he had 20 and 310 sold. So we're going to type this information into our calculator to find the correlation coefficient. When we type it in, we're going to ignore the week. So it's kind of like our number of advertisements is our X and our number of specialty items sold is our Y. Before you can use the statistics function in your calculator, you have to go to mode and make sure your stat diagnostics is on. So we're going to go to the calculator. First, clear it to make sure you're starting good. So second plus 712. Well, that didn't work. Okay, so it's cleared. We're all good. Then you're going to go to mode and find stat diagnostics. Stat diagnostics by default is off. You need to turn it to on. Once you have on selected, push second mode to get out of that screen. And now we can start actually working our problem. We're going to go to stat, edit. L1 is your X column and L2 is your Y column. You will not use any of the other columns after that. So let's label that our number of advertisements, that's our L1. And our number of specialty items sold will be our L2. So we're going to type all of the numbers into the table. So in your calculator in L1, you have 6, and then 20, and then 1, 14, 25, 16, 28, 18, 10, 8. Then move over to L2. Your L2 column, the number of specialty items, 150, 310, 100, 160, 280, 200, 400, 250, 120, 150. Okay, now that you have everything typed into your calculator, we're going to get out of that, so second mode. Then you're going to push stat again, but this time you're not editing, you are calculating. We're going to calculate the linear regression. That's option number 4. So when you have linear REG, stands for linear regression, push enter. Your X1 list is going to be the L1. Yours is probably already populated that way, but I need mine to say L1 and L2. Okay, so yours was probably automatically populated to all of that. Mine, I had to type some stuff in. You shouldn't have to type all those things in. You should just be able to push enter all the way through and it will take you to this information. So here's how you read this. If ax plus b is like our equation, we're used to saying mx plus b. So a is in the place of the slope. That is our m. That's our slope. So this equation has a slope of 10.37, a y-intercept or b of 60.55 or so, and then r is 0.923. So if we put all of those numbers onto our paper, we have r is 0.923. Do not use r squared, always use r. That's the correlation coefficient. This number r is a positive number. And if we use our chart on the page before, a 0.9 is a very strong correlation. Now, the equation that best fits this data, the line of best fit, is y equals, instead of m, remember we had a, kind of weird, but y equals 10.37 x, and I just write 2 or 3 decimal places, plus b was 60.55. So you can round to 2 decimal places, you can write 2 decimal places. Either way, you're going to get pretty close, okay? That's all the information we can come up with from this table. The correlation coefficient, R, tells us it's a strong positive correlation. So these two things that very much have something to do with each other. And the equation for the line that best fits the data is y equals 10.37x plus 60.55. Now, this question asked me how many specialty items we labeled Y. So what is the Y value that they can expect to sell at the hot dog hut if Hugo can only afford to pay for 11 advertisements? Well, the number of advertisements is our X. So what we're going to do to figure this information out is we are going to take our equation and we're going to figure out what would the answer be if I had X or 11 advertisements. So if I know Y equals 10.37x plus 60.55. I'm going to take the x out and replace it with 11 because that's what my x is equal to. So y equals 10.37. Instead of x, I have 11 plus 60.55. Now I need to figure out what is y. So if we go back to the calculator and go back to just the normal calculator screen, we have 10.37 times 11 plus 60.55. We get 174.62, which is about, so 174.62. Our question wants to know how many items can they sell. Well, he's not going to sell 0.62 of an item, so we're going to estimate that Hugo can sell, or Hugo would expect to sell 174 items. All right, so we used our line of best fit to make an estimation about what could happen later. Not hard. Okay, the next example. In 2000, a construction company implemented a safety education program. The graph below shows the number of incidents reported each year since the safety education program started. So again, we need numbers to put in a table for L1. L1 we said was our X's, and L2, which we said was Y. So I need to build a table from these points so that I have a table I can type into my calculator. So I'm going to come over to the side and I'm going to build a table. My X's or my L1s will be on the left, and my Y's or my L2s will be on the right. So if I just take it a point at a time, we're going to have to estimate some of these values, but we should get close enough to come up with a good answer. So this point here has an X value at 0, a Y value at 40. This point has an X value at 1, and the Y value is 37-ish, about 37. This point has an X at 2 and a Y at 31. This point has an X at 3 and a Y at 35. This point has an X value at 4 and a Y at 36. This point has an X at 5 and a Y at 30. This point has an X at 6 and a Y of 32. This point has an X at 7 and a Y at 33. And I'm out of room, so I'm going to continue my table over here. This point has an X at 8 and a Y at 30. This point has an X at 9 and a Y of 23. This point has an X at 10 and a Y of 22. This point has an X at 11 and a Y at 25. This point has an X at 12 and a Y at 26. This point has an X of 13 and Y at 22. This point x is 14, y is 23. And this last point, x is 15, and y is 21. Okay, now we have to go to our calculator. In order to find the correlation coefficient in the equation, we need to type all of that into the stat function. So in your calculator, you're going to go to stat. We are editing again. Okay, now to delete all these numbers, it's kind of a pain. But you're going to go to each box and say delete, enter. Delete, enter, delete, enter, delete, enter. There's a couple ways you can do it, but this is the way I like to do it so that I don't make any mistakes. If you delete the L1 or L2, then it will mess you up. So you have to make sure you delete only the numbers. Okay, so now if I'm going to type all of those points into my equation, my first point was 0. So my x values are basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My y values are 40, 37, 31, 35, 36, 30, 32, 33, 30, 23, 22, 25, 26, 22, 23, and 21. All right, then we're going to get out of that. We're going to go back to stat, but now we're going to calculate the linear regression. L1, L2. Again, yours should already say these things. Okay, so we have an A value or a slope, an M, of negative 1.167, a B value or y-intercept of 37.88, an R squared we don't care about, but an R value of 0.9. Now, my calculator is a little bit different than yours because it's telling me that I have a positive R value, but we can tell when we look at the graph that this situation trends in a negative direction. So my R value has to be a negative value. So instead of taking that 0.1, we're going to say it's negative 0.1. Your calculator should put the negative on there, but mine does not. But it makes sense. So the R value is how strongly you have a correlation or how your information is trending. And as I move on, as my x's get bigger, my y values are declining in general. So that's why our R value has to be a negative. So we know this is a negative correlation. Because it's 0.9, that's very strong. And the equation, so the equation we got is y equals negative 1.167, I'm just going to stop there, x plus 37.882, approximately. Remember, we're just making some estimations so we can get close, okay? Okay, now we're going to use the equation to answer this question. Based on this information, how many safety incidents could the construction company expect to have in the year 2020? Well, so if this is the number of years since 2000, I'm not going to use the number 2020. I'm going to use just the number 20. So if my situation kept going, about where would I hit if I got to 20? So we want x to be 20. So we need x to be 20. So I'm going to rewrite my equation, y equals negative 1.167. Instead of x, we're going to use 20 plus 37.882. And then I'm going to solve for y. So if we go back to the calculator, we're on the normal calculator screen. So we have negative 1.167 times 20 plus 37.882, 14.542. So 14.542 y equals 14.542. So if I want to know how many I can expect, we're not going to have 0.5 of an incident. So I would say that the company could expect 14 incidents. Now, some people will argue that because it's 14.5, you should round it up and say the company should expect 15 incidents. That's fine. Remember, you have to remember we're just making an estimation. We just want a number that's close so that the company can prepare for what maybe would come. You can tell because our dots are not following a linear line every time that it's going to jump. It's not going to be perfect. We're not going to come up with a perfect answer to be able to tell this company how many incidents for sure they'll have in the year 2020. But we can tell them that 14 or 15 is going to get them close. If a question like this was on the STAR test as a multiple choice question, the numbers would be very far apart. So if you got 14 and your partner got 15 because you rounded the decimals in your equation different, you're both going to end up with the same closest answer. So totally not a big deal. So that's all. That's all we have on linear regression, correlation coefficients, line of best fits. It's really easy, but it's a calculator skill that needs to be practiced. All right?